Click the bell icon to get latest videos from Ekeeda.
Hello friends, in this video we are going to learn active differentiator. In previous video we have seen integrator where the output voltage is proportional to the integration of an input voltage. Whereas here if you see the name itself is explanatory, that is active differentiator. Since it is an active differentiator, the element used to design the circuit must be the active element. So we are going to implement this by using op-amp as an active element. Differentiator, that means output voltage will be proportional to the differentiation of the input voltage. Now before we understand and derive the output voltage for a differentiator, let's see its circuit diagram. As we have learned the integrator, here if you see the differentiator circuit diagram, it is nothing but only the place of the capacitor and resistor is interchange. So the resistance was connected over here and capacitor was connected in a feedback path in a integrator, but if in differentiator only the place is interchange. So here capacitor is connected to input, that means the input which is to be amplified or which is to be processed by op-amp is given through the capacitor to the inverting terminal. That means we can say this is the inverting configuration of operational amplifier, and also the non-inverting terminal is a grounded. So input signal is applied to the capacitor. Capacitor block DC content, there will be no processing of a DC content because the capacitor is connected at the input side. So it will only work for the AC input voltage. So in AC input voltage at low frequencies, reactance of this capacitor, that is XC, is equal to 1 by 2 pi Fc. Now from this formula you can say that at low frequencies, if frequency is low, the reactance will be high, that Xc will be high, and it will result in low gain because it will be Rf divided by Xc. If Xc is high, the denominator is high, the gain will be less. This is the formula for gain. At high frequency, because when you take the AC signal, your output will depend upon the frequency. At high frequencies, the reactance, if frequency is high, the reactance will be low, and if reactance will be low, that is the denominator, then it will result in a high gain. So this is how the differentiator will work on a different frequencies. Let's see the analysis. I is equal to IF, and IF is nothing but minus V out divided by RF, because since there is no current flow, the non-inverting terminal is a grounded, so that means inverting terminal should also be the grounded. So that will be that. Here you can see, if I draw the diagram again, this plus is grounded, and here we have connected to the capacitor and the resistance. So in this case, this point will be at zero potential and this point will also be at a zero potential. So this expression, that is IF, which is the current flowing through this, will be minus of V out, because it will be, if you assume that this point is equal to X, you can write this expression is equal to IF is equal to Vx, that is the voltage at this point, minus V out divided by RF. Since this Vx is equal to 0, the expression will come out to be minus V out divided by RF. Now let's see what is the charge on the capacitor. Charge on the capacitor is equal to the capacitance times voltage across the capacitor. Now voltage across the capacitor is nothing but, we can write it as a Vc, which is nothing but V in, which is applied to this terminal. So charge on the capacitor is equal to Q is nothing but value of a capacitor into the input voltage, because here input voltage is directly given to the capacitor. The rate of change of this charge will keep on changing based on time. So what is the rate of the change of this charge is? It will be changed as per the time. So it is d by dt of q. That means change in a charge with respect to time can be written as, you have to take the derivative of this side, and that will be C will be the constant, that is the value of capacitor, d by dt of V in, because if there is a change in input voltage, there will be change in a charge of the capacitor. So dq by dt is nothing but value of a capacitor dv in by dt. But now we know that this dq by dt is nothing but the capacitor current, that is the current flowing through the capacitor, that is this current I. So we can write I is equal to C into dv in by dt. So here we have written that I is equal to IF. So here if I is equal to this value, this is nothing but value of IF. So in this case, we can write down this expression as minus V out by RF, that is nothing but I is equal to C dV in by dt, where this value represents the value of IF and this value represent I. This is nothing but our first expression we have derived. So we want to derive the value of V out, that is the output voltage. So let's take RF at this side. You will get V out is equal to minus sign bring here, so minus RF into C V in by dt. So from this expression it is clear that output voltage is proportional to the derivative of input voltage. So hence the name for this circuit is given as a differentiator, and here this is minus RFC is nothing but the time constant. So this time constant is a scaling factor, you can say, to scale the input voltage. Now example of a differentiator, if you give the input is equal to sine wave, your output will be positive cosine wave. Here negative sign indicates that you are assuming the inverting configuration. Since the input is given to the inverting configuration, your output voltage will be 180-degree phase shifted. So hence we have the negative input. So I hope you must have understood what is the differentiator is and how the expression for output voltage for differentiated can be derived. Thank you for watching this video. Stay tuned to Ekeeda. Do subscribe Ekeeda. Thank you so much.